Hello everyone, this is Prabhakaran. In this video, we are going to see about the implementation of tree search. Basically, the implementation of tree search is done in serial and also in parallel manner. And also, we are going to see some of the real-time application where the tree search actually used. Yeah, let's get enter into serial and parallel implementation of TSP, that is tree search problem. Okay, basically for the construction of tree search, we will be considering two tour, that is the partial tour and cost of the tour. The algorithm is used here to find the least cost tour is the DFS algorithm, depth first search algorithm, where the input will be the search tree and output is to find the least cost tour. Then when come to serial mode of implementation, the algorithm used here in the DFS is first point, they have to start from the root node. They have to identify which is the root node, and second, they have to traverse through the leftmost tree node to the deepest leaf node. Okay. Third, they have to go back to the deepest ancestor tree node and traverse with the unvisited children till the leaf node has to be identified. Then we have to repeat that particular step again and again till until the completion of the least cost tour. So that's the algorithm basically used here in the DFS. And when come to serial implementation of TSP, they rely on both recursive DFS and non-recursive DFS. So what actually is recursive DFS? Where recursive DFS used to find the feasible solution, where it undergoes the recursion techniques, and this DFS function will be called recursively for each and every node. But when come to the parallel mode of implementation, this type of recursive DFS will not be much more efficient. So to overcome from that problem, since the function calls are expensive, recursion may lead to slowdown of the performance. To overcome that process, the alter method used here is non-recursive DFS. That is the second mode of serial implementation, that is non-recursive DFS. Non-recursive DFS has no recursive function in it, and it is much more useful when the parallel implementation is done. Yeah, that the type in the serial implementation. Now let's enter into the parallel implementation. So what is actually is parallel implementation in TSP and how come it is used over there? Okay, so task. Each tree node can be specified as a task. Every tree node can be specified as a task. Down edges. Now that particular task will communicate with the down edges over there, and partial tour is feasible or not. Okay, so each task should ensure that whether the partial tour is feasible or not. If the task associated with that leaf node found that its tour is better one with the minimum cost, then it will be updated tour as the best tour. All the path will be calculated and it will end in finding the least cost tour, and it will check with the previous one whether it is the minimum cost, or else until it will search for the minimum cost and it will update the result, that is this is the final minimum cost tour. And the Foster design methodology, as said in the Foster design methodology, you are all convenient. I think you are all convenient about Foster design methodology. Basically, Foster methodology will involve in converting the problem into small number of sub problems. That is, they will get into the partitioning, and after partitioning, each sub programs will get communicate with one another, and after the communication, the agglomeration process will take place. Once the agglomeration gets completed, mapping functionality will take place in the Foster design methodology. Yes, as in the Foster design methodology, the task to be divided into subtasks, as it said, and communication also carried out by updating the cost of the tour. Okay, And the importance over here, out of the all other 4-step methodology, mapping take place very important applications of tree search. Now look into this particular slide. There are n number of applications over there for tree search. Here I mentioned so few. Okay, first one is maze games, second one computer networks, third is wireless technology, especially for the electronics and communication field, and GPS navigation system, finally the popular social network Facebook. Let's see one by one how the application is actually using the tree search here. Now the first real-time example, maze games. Look into the following picture. The particular boy have to find the right path to go to the destination. Now consider the case in the tree search method. Basically in tree search we will handle with edges, nodes, vertices, right? Now look into this particular maze games into a tree search problem. Maze games which you solve on magazines, basically you will get solved in magazines, right? Or created by the depth first search algorithm. It is full of based on DFS algorithm. The logic is same. It begins from the root element, which is the beginning point. We will be calling it as root element. The beginning point will be called as root element. It explores other unexplored edges and backtrack to find the correct solution. That's happened in maze games. Now look into the second example, computer networks. Okay, so everything is connected to the networks, all the communication medium and ports also communicated in networks. Now in this computer networks, peer-to-peer application such as now let us take an example of torrent. Okay, peer-to-peer application such as the torrent clients need to locate a file that the client, for example, one who want to download a file is requesting for that particular file. This is achieved by applying BFS on the host. That is nothing but one who supplies the file, right, on a network. Now your computer is the host and it keeps traversing through the network to find the host for the required file. That's what happened in computer networks. Now wireless technology. So electronics and communication use this in terms of communication, right? Wireless technology. As users of wireless technology, they demand high data rates behind the gigabits per second for voice or else for the video and some other applications. There are many standards to achieve data rates beyond the gigabits per second. One important standard is MIMO. That is nothing but multi-input, multi-output. MIMO, that is multi-input and multi-output, employs a best algorithm called as K-best algorithm, which is actually nothing but a BFS algorithm, which is breadth first search algorithm, to find the shortest path distances. That's what happened in the wireless technology, to find the shortest path between that particular communication. Now look into the fourth one, GPS navigation system. One of the most important application, right, which we are using in our day-to-day life, the navigation system. The navigation system such as Google Maps, which can give direction to reach from one place to another. Consider if you are in a one place and you want to go for the one, consider your place as a source, and if you want to go for some other destination places, it will show the several routes and also it will mention the shortest path using the algorithm called as BFS. They take your location to the source node. Okay, they will fetch your location to the source node and your destination will act as a destination node. Source node is nothing but your location. Destination node is nothing but the destination which you are going to go point, okay, on a graph. Consider a city can be represented as a graph by taking a landmarks as a nodes and the roads are taken as an edges. The city will be taken as a graph and the roads will be taken as a edges that connect the nodes in a graph. Now BF is applied and the shortest route is generated, which is used to give the direction and real-time navigation. The most important thing finally is the Facebook, one of the commonly and most used social network platform, Facebook. How actually tree search is used in Facebook? Let's see that. Actually, Facebook treats each user profile as a node on the graph. Facebook treat each user profile as a node on the graph, and two nodes are to be connected if they are each other friends. In fact, apply BFS on the Facebook graph and you will find that any two people are connected with each other by at most 5 nodes in between. To say that you can reach any random person in the world by traveling 5 nodes in between them. Yeah, so these are the real-time applications of. Thank you so much for your patience listening. Stay connected, do good, be good. Thank you all. Thank you so much for your patience listening. Stay connected, do good, be good. Thank you all.